Good morning, everyone. Hi, it's great to be here. My name is Johnny Lee, and I'm excited to give you an update on where we are with Project Tango. For those of you who are less familiar with Project Tango, one of the core beliefs and ideas behind this project is the fact that when we place our mobile phones on a table, they don't actually understand the things that are around them. They don't understand the extent of the table or the room that they're in. In fact, almost all of the information that they provide us is constrained to this little rectangle you see here. They don't understand if we're relaxing at home with family, or if we're in our workspace collaborating with our coworkers, or in a large lecture hall, such as this, all facing in the same direction, or having a nice, intimate dinner with friends and family. And what we do heavily depends on where we are. How we feel, how we talk, how we share information with each other, all depend on this context of where. And so, rather than try to force our entire lives into this very small rectangle, what Project Tango is trying to strive for is developing the hardware and software technologies to help everything and everyone understand precisely where they are, anywhere. Not just where there's good GPS coverage, good Wi-Fi coverage, or Bluetooth beacons, but any building, any space, anywhere where we can go, the devices and tools that we use also share this understanding of space. So last year, we introduced our Project Tango tablet development kit. And this was the first mobile device with the sensors and software to start to work toward this journey. It includes a 4-megapixel, 2-micron camera, integrated motion tracking camera, and an integrated depth sensor. And all of these sensors, combined with the Project Tango software stack, allow devices to understand the physical movement of the device, as well as its surroundings. If you actually look at, although we announced the tablet over a year ago, if you actually look at the GFX bench, which is a very popular graphics benchmark for mobile devices, using the Manhattan 3.0 test, the Project Tango devices still rank among the highest marks with regard to processor performance of ARM-based devices. We're also really happy to share that since last year, we've also started shipping our dev kits. And 3,000 units are in the field, in the hands of developers working on hundreds of apps. In a partnership with NASA, we are also able to have 2 of our devices, early prototypes, shipped up to the International Space Station atop a 530,000-pound Antares rocket from Orbital Sciences. This collaboration and partnership is allowing NASA researchers to use the technology in Tango to one day help robots potentially autonomously navigate the space station. So what happens when you have devices that actually have this sensing capability? Well, there's a few different categories that we think are really interesting. One of which is indoor navigation. You could imagine their devices one day not just being able to take you to the front door of a building, but could actually navigate you all the way to the door of the room that you wanted to get to. There's a project inside of Google starting to use Project Tango devices to explore helping the visually impaired navigate indoor spaces. You can also use the tracking and spatial reasoning of the device to transform parts of your home into a game environment. So I can build a castle in my living room and build a forest in my bedroom. And of course, there's emerging new areas that are all starting to get exciting, such as robotics, AR, and VR, which are all potentially enabled by the 3D tracking capabilities in Tango as well. So to give you a briefing, the core technologies of a Project Tango device and the software stack that goes on top of it break into 3 different categories. The first is motion tracking, the second is area learning, and lastly, depth perception. So motion tracking is actually very similar to your computer mouse. If you imagine taking your mouse and putting it on the table, as you move it around on the flat surface, it tells you the relative position you are when you put it on the table. Project Tango devices are very similar. When you first start your app, it tells you your relative motion relative to when the app started, but instead of just being constrained to 2D, it actually is full 3D. You get X, Y, Z, as well as 3 degrees of rotation. The second major concept is area learning. And if you imagine closing your eyes, you actually have sort of a mental memory of the shape of Moscone. You know roughly where you are in this building, you know roughly how big the room is, as well as your own location within this room. And it is that memory that we call area learning. So when a Project Tango device enters a space that it's previously been in, as it starts to explore the space, it will build a map. And when it recognizes a landmark it's seen before, it can localize itself to the rest of the building. And that's called area learning. The last major concept that Project Tango devices provide is depth perception. So in Project Tango compliant devices, we include a depth sensor that uses infrared signals to measure the distance to points in space. This allows us to detect the floor, the walls, and furniture in the environment, and potentially allows your application or game to respond to the user's space. Now, over the past year, we've made a ton of improvements to the software stack, and this is just a few of them. This has been done in collaboration with some of our early access partners that we gave devices to, and we've really appreciated their feedback as we've continued to push and push the features of the system. Now, unfortunately, due to time, there's no way I could actually talk through all of these. So instead, I'm going to show you a short video that illustrates some of these capabilities in action. Can we dim the lights? Thanks. It's pretty neat stuff, isn't it? And it's all working in real time on our tablet development kits. Some of those videos are very early proof of concepts in our lab, and so we're happy to sort of share the results as we develop them. Now, because a lot of these actually run in real time, I actually do want to try to demo this stuff for you live. So if we could switch over to the tablet. Great. So what we have here is a diagnostic screen that just shows off kind of what's going on under the hood. Again, we have our, this is the raw image from the motion tracking camera. This is a wide angle camera that gives us a large view of the environment. In fact, I can see my fingers holding the device. And you see these green dots that are colored in various different ways, and these represent the optical computer vision work that's going on that actually is tracking the flow of the image in the camera scene. We combine this data with the gyro and accelerometer in a tight sensor fusion stack to generate the plot in the upper right. And so like any mobile device, they can turn left and right, and you can see it responds to my movement. But what's special about a Project Tango device is that I'm able to actually move with and walk around the room. So if I draw a circle with the device, it continues to track in 3D, and I can walk off the stage and reasonably aggressively walk around and hold it, and it continues to track my position fairly robustly and accurately. So again, I could just unplug the HDMI cable. I'm actually tethered by this wire so you guys can see what's on the screen. But this would allow a user to walk around their entire house or the entire building and continue to have full 3D tracking. Now I want to show you just a couple of simple demos just using the motion tracking capability. So this is a quick test demo. It's sort of an homage to some very popular world-building applications. And all I am doing is what's here is a simple open grid. And you can see I have this reticle in the middle. And all I have to do is move the device, and it controls the virtual camera inside of Unity. If I use the tablet, I can point at the ground and push this add button, which will place a block. And if I add a few more blocks, I can start building the foundation, a little plot of land, to build a small building. Okay. So you can see it's pretty natural. All I have to do is just use it like a camera controller. And I bring up this menu, and I can build bricks. I can choose bricks to build a little ground line like this. And I'm just pointing with the tablet and hitting the button, and I can actually control it quite nicely and precisely, quite quickly. So I'm placing pillars for windows. Let me add a roof line. Okay, so now I have my walls built, and let me build a little wooden roof. Okay. Here we go. So just in about a minute or so, I was able to build this little structure that's located here in the middle of the screen, middle of the stage. And I can walk to left and right and look at it from different angles. And because I have full 6-degree freedom tracking, if I want to, I can just lean in, actually go inside the house, like this. So I switched to a stone brick, and now I can start decorating the inside of the house. I did make a kind of a small house, so I can't do a whole lot in it. But the neat thing about it is that this building is actually here in the middle of the stage. If I come over here to this part, here, I can build a small tower. And these objects are actually physically located in space. So you can imagine if I actually had a multiplayer version of this, I could build with my brother or sister or my friends sort of in a collaborative manner, and we could all be using physical space in the same way as though we were stacking with real physical objects. One of the things we wanted to do was make sure that working with the Tango tablets were actually very easy for people who already had 3D assets. So Otherworld is a game developer that we helped, or we asked to see if they'd be willing to port a game that they already had, which was based inside of Unity, to the Tango platform. And if you use the SDK, it's actually quite simple. Within a matter of a couple hours, you can take a 3D asset and Unity game you already have and make it Tango enabled. So this is a world where I have to help this ship dodge these enemies. And in a normal game, in a normal device, you would either tap the screen to rotate where you are on the planet, or rotate your head with the gyroscope. But because we have full 6-degree freedom tracking, I can actually walk around and look at the planet from different sides. If I want to go above the planet, I can dodge these crystals and sort of navigate him through this space as if this globe was floating in front of me and about 2 or 3 feet away. I can also back up and start throwing asteroids from the planet, like this, by touching the asteroid belt. So this is just a demonstration of how you might enable 6-degree freedom input into existing game assets. The other thing that we've been asked by our developer community was being able to bring in geometry of the real world into the game engine. So part of the sample code that we have on Project Tango website is this app, which is called Mesh Builder. And what it's doing is actually using the depth sensor combined with the 3D tracking to do a real-time 3D scan of the stage. So I have this small table here with this basket. And you can see as I walk around the stage, it's actually progressively building this mesh. And because this is all running real-time inside of Unity, I can throw balls on it, and we're updating the physics in real time as well. So this basket is actually a little bit too small for these balls. So let me take this one away and give myself a slightly more generous basket right there. So let me clear this and rescan it. And you can see it kind of has the larger basket. It's progressively building itself in. And now if I back up, I can try to play basketball. Oh, come on. Yeah. So with a little bit of additional help and some procedural game geometry, you could actually turn this table into a plateau or a mesa. You could actually literally have someone building a set of cushions with their couch, and you could turn that into a castle and have your characters actually run around furniture. When we first got this working, we were like taping up blankets in our office and using them as ramps for the ball. Another simple utility that we've been asked for with the sensors that you can do, with the sensors that we have in a Tango device, is being able to simply measure the environment. So imagine we are shopping for a new table, or I have a new bed that I want to move into the space. We can use the tracking data as well as the 3D sensing data to give us a simple visual tape measure. So for example, if I want to measure the size of this table, I simply use this crosshair, point it at the table. Whoop. Let me try that again. I'm going to do it down here. Okay. So that gives us a rough measurement of the environment between those 2 points. All I had to do was point the device like it's a cursor, and I can see the distance between these 2 corners and come over here. And just by pushing this button, we get a rough measurement of the footprint of this table. The other nice thing about this is that you don't have to be constrained to flat surfaces. If I am trying to, say, park a truck where I have all my furniture still inside of it, I'm trying to figure out if I can get through this gap. I can measure from this podium to this wall, and it'll give us a measurement in free space, just like that. So there's a variety of professional applications you could already start with, imagining being able to make use of this technology and capability. The last demo I want to show you is from a partner called Invive. And what they do is they specialize in product visualizations. They do high-end apartment complexes. They do products such as cars and refrigerators. And so we have been working with them, and they have this simple car visualizer. I need to actually point in this direction so that we can actually place the car on the stage. Let me actually pick it up and move it so it's not touching the table. There we go. So I can simply walk around this car. Because it's actually a full-size metric car, it actually doesn't quite fit on the stage. So I'm going to use the power of software and shrink the car. There we go. Okay. So now it's almost toy size now, but I can sort of look around. I can look at the wheels. I can double tap the hood, and it'll open up the engine. I can get up close to the engine and talk about the different parts inside of it, the respirator, the carburetor, the engine hood. Obviously, you can do customizations to the visualizer, such as making it a nice racing red or a midnight blue. I think I can also go and do body upgrades, which will show different parts of the car that I can edit and modify. So let me select the roof and give it an upgrade. And just for good measure, let me scale it back up to normal size, which will actually allow me to get in the car. But there's not quite enough stage space, so I'm just going to go right through the windshield. But here I can actually see the in-car dashboard, the steering wheel, the seats. If I want to, I can adjust the interior styles as well, and interior colors. So this is just another simple example of our Unity integration, and we started improving the AR quality of performance, the registration, and again, it's important to realize that this is all using motion tracking. There's no pre-existing map of the stage, and we could easily do this in any environment, including your home or a showroom or a retail space. Okay, so those are the demos. Can we go back to the laptop? A couple other demos that I unfortunately can't do on stage or that's very difficult to demonstrate is, of course, things like VR. VR has obviously made a lot of news and press recently, and the 6-DoF tracking and positioning that Project Tango enables is interesting for VR. So we've started exploring docking these tablets to your face using the Durovis dive helmets. Durovis is a partner that creates these plastic shells for different size mobile devices. It's obviously not the most ergonomically friendly form factor. And these tablets were not designed for VR. They have high latency, they don't have quite the right rendering stack, but from a sensor and tracking standpoint, they seem to be performing relatively well. So if you have time, you can go out to our sandbox area, and you could experience this village scene in VR. You can look on the ground and get sort of to the ground level of the people and look around the different bases. We also have a prototype of doing multi-user VR. Because we have fully self-contained devices, having multiple people in the same space is largely a matter of just getting the Wi-Fi connection working and having positions shared among each other. The great thing about this is that you can actually put on the helmet and you can see each other in VR and have an actual conversation. The mouths actually move to your vocal, to the sound. If you were on the sandbox area, you probably also saw one of these. This is a prototype that we built with Hasbro. They have the Nerf brand guns, and what they did is they built a 3D mount that goes on the rail system of the gun, and you just put a Project Tango enabled device, and it allows you to actually run around the room in a first-person shooter. You can turn and shoot the enemies from left to right, but you can also move and duck behind the boxes in the space. It's a lot of fun to actually play, and so I encourage you to try this one out. So we're really excited and proud to have a large number of partners that have helped us mature this platform, both from a software and hardware standpoint. And we hope to grow this network and community with hopefully some of you in this audience we can add to this list. So Project Tango devices, we feel, enable a new form of digital playground. We can put virtual objects in the same physical space that's meaningful to people. We can actually navigate you to the item that you're really interested in a space that you've perhaps never been before. We can also help you make decisions about where to go in areas where GPS may not be good enough. We can enable you to not only create 3D stories that you can look around by turning your head, but you can actually get up and walk through. And I think this is an interesting dimension that we're only beginning to explore as a community. Obviously, we're all very excited about the emergence and maturity of AR, and 3D tracking and registration is a core component of making a good user experience. And when you combine that tracking ability with information about the environment, you can actually see beyond the physical limits of your space. And we also know about robotics and drones, and I know I've been enthusiastic and bought one of these myself, but I also crashed it in the first 30 minutes. So onboard mobile 3D positional tracking and 3D sensing is important for things like collision avoidance and autonomy. So we also see the technology in these devices being relevant to this domain as well. So this is our Project Tango development kit with a high-performance 2-micron, 4-megapixel camera, motion tracking camera, integrated depth sensing, the Tegra K1 processor with 128 gigabytes of storage and 4 gigabytes of RAM, which is on par with a lot of laptops. And before we had to request that developers apply on our website to get one of these, so there was a relatively limited distribution. But we're actually happy to announce that earlier this week, we opened up purchasing to anyone in the United States, with international locations coming soon. We're also happy to say that we are offering these at our reduced price of $512. Given the actual specs of this device, this is actually a pretty aggressive price point. To celebrate this new availability of the devices, we are also kicking off our first app development contest. So this is an effort to seed app development and seed content on our platform. There's 3 categories to the contest. You can choose to build a utility app, such as measurement, navigation, room scanning, or object scanning. We have a category for AR and VR use cases. And of course, gaming and entertainment, which I think is one of the ones it's very easy to imagine seeing demos in this space. We have seed money for each milestone for each category, which exponentially increases. So 16 selected proposals will get $1,024. 4 selected working prototypes after that milestone will get up to $2,048. And then each category will have 1 final app selected with $4,096. Once all the final apps have been submitted, we'll have a user-driven contest-wide grand prize of $8,192. All told together, this is a total cash awards up to $95,000. And we hope this won't be the last contest we run. So proposal entries start today. And the first deadline that you should be aware of is June 25th, which is a deadline for proposals. The final APK entry will have to be submitted by September 23rd. To find out more information about how to enter the contest and details, please visit our Project Tango Google+ community page. So, $95,000 to help seed the app development community, and we hope that this helps bring up and surface new partners that we actually want to work with more deeply and make a stronger relationship with. We are really excited about the tech inside of Project Tango, and we hope that one day it can be as ubiquitous as GPS. But we also know that before we used to be fine with phones that didn't have GPS. We knew how to get from home to work. We knew how to get to our restaurants just fine. But now we wouldn't even consider buying a phone without navigation directions. And I think we believe that the technology inside of Project Tango would enable this sort of feeling as well. But we also know that to become ubiquitous as GPS, tablets aren't necessarily the best form factor. I'll be the first to admit that a 7-inch tablet doesn't really fit in my pocket. And we'd love to be able to have people carry this around with them all the time. And so that's why we're also excited to announce today a new partnership. And that's with Qualcomm. Qualcomm is the largest manufacturer of mobile phone processors today, and we've been working with them over the past few months to try to incorporate Project Tango technologies onto their chipsets. And this is with great support from Raj Talluri, Senior Vice President at Qualcomm, who is right here in the audience. Do you want to stand up and say hi? Thanks. We first met Raj earlier this year, and we sat down and talked about the future of Project Tango and our goals and the future of mobile computing. And we both agreed. And we agreed that computer vision and 3D tracking was going to be an essential part of new mobile experiences, from indoor navigation to VR, AR, and potentially robotics. And we understood that to actually achieve the price and power and performance requirements of these new demanding applications required developing new hardware and new software. And so we've been working with very tightly with Qualcomm engineers to modify their mobile development platform, or MDP, to incorporate Project Tango sensors. So this is a modified version of Qualcomm's Snapdragon 810 MDP platform. We've incorporated it with the motion tracking camera, a new depth sensing camera, which is time of flight based from a partner called PMD Technologies, an RGB camera, and time-stamped gyro and accelerometer. And these are all of the things that you need in order to support the software's experiences that we want to do on these hardware. So these MDP platforms are the reference designs provided to device manufacturers to accelerate the design of their next generation phones using Qualcomm chipsets. So by working with Qualcomm and building these devices, we can not only optimize Project Tango software to the Snapdragon chipset, we can also accelerate the rate of adoption in mobile phones. Now, it's important to remember that these are engineering reference designs, so there's not a plan to manufacture a large quantity of these. The best platform right now that you can purchase today is the Project Tango tablet. But these will be given to OEMs as well as software developers to optimize some of their applications to the Snapdragon chipset. We're really excited about this partnership because we believe it's a large milestone in being able to bring this technology to the pockets of millions and billions of users. So we're excited about this future. So today, you can now purchase a Project Tango development kit and actually start writing apps as early as next week. We hope to see what people can do with this platform. We've started a contest to enable the applications that we'll see tomorrow, and we hope to find new partners that we can engage in more deeply. And we're continuing to invest heavily in the software and hardware required to take this technology into more form factors, including the mobile phone and beyond. So this is an investment in things to come. We see the exciting things that technology is developing, and we believe the future is genuinely awesome if we can work together and bring this technology to people. Thank you very much. It does look like we have about 6 minutes for questions, if anyone has any. Oh, I think it's best to walk up to the microphone if you do have a question. I forgot to mention we are hiring, so you can go to our website and look at our job listings. The development kits and the contest information can be found on our website and Google+ page.
Hi. About the motion tracking API,
yes.
Could you comment on the accuracy of the position and pose given out by the SDK?
Sure. So when the system is happy, the accuracy is about 1%. So with 100 feet of travel, we drift about 1 foot. So it's a function of distance travel.
Okay, and you can say in percentage.
Yes, it's more accurate to talk about percentage because if you go a long distance, it'll change. Yeah.
All right, thank you.
Yeah.
Hello. The contest is open to all developers worldwide or only for
yes.
US? It is open?
Yes.
Thank you.
Oh, yeah, the Qualcomm device is actually on display in the sandbox area.
Hello. So one of the demos showed a user biking into the city and then doing real-time mapping.
Yes.
So how does the hardware deal with being used outside and on indoor?
So the motion tracking camera is a visible light imager. So it works fine indoors and outdoors. The positional tracking and all of the orientation information uses just that camera and the inertial sensor. So indoors and outdoors is not a problem.
So it can do object detection outdoor as well?
The tracking can work outdoors. The depth sensors have a harder problem. Some depth sensors have more sunlight robustness than others. And so depending on the technology being used, the outdoor performance of depth specifically will vary.
Okay. And you also mentioned using the Tango tablet for AR and virtual reality.
Yes.
What would be the latency in the amount of data coming back from the sensor and back to the application?
So the primary sensor that drives a lot of the frame updates in VR is actually the gyro. As you move your head, that's the one that creates the most significant visual feedback. So there's no reason why in a properly optimized hardware that the gyro performance would be any different from another VR headset. But the tablets here are running stock Android, and there's not any particular latency optimizations on these devices. So these devices are around 80 milliseconds or so. But as I mentioned, they're not optimized for low latency performance.
Okay, thank you.
You showed the screenshot of the multi-user VR chat. How are the relative positions between the multiple users determined?
Sure. So that's a good question. So each device, when it first boots up, is its own coordinate frame. So what we have is the area description files, which is the pre-existing coordinate system for the room. So by sharing the area description file with multiple devices, either by pushing those over the network or by copying them manually, all the devices will boot up and localize to the same room, essentially.
And that works by detecting features in the room and like mapping it to that relative to the area description file, or?
Right. The area description file is a visual description of the environment, which includes features and matches in that space. So just like it would be a description of this room, and as long as we all shared the same reference of the room, we can all adjust our coordinate system to match this coordinate system of the room.
Great, thanks.
Yeah.
We have time for one final question.
Hi. Two quick questions, please.
Yeah.
How good does it work in large rooms with high ceilings? Like, for instance, this room, if we would like to map it, the whole room, the entire whole room, how accurate could it be?
So 1% is probably still the best metric I can provide. So the further you are from objects, the more ambiguity there is in the positioning. So on the stage, while a large percentage of the room was empty, I was still able to see the content on the stage. And so this kept my positional accuracy on the order of a few millimeters to a centimeter. If I went out into the hallway and only pointed at the ceiling, the error would go up. But as you walk around and build more observations of the room, it can become more precise over time.
Okay, and thank you. And the second question is it possible to anchor a specific point to a longitude, latitude references to a geolocation?
Yes, so in our indoor navigation proof of concept, we're currently doing that and geolocating our area description files. So that requires some other reference to say, well, I know the origin of the room, but where's the origin of the room on the planet?
Right.
So one of the things you can use, of course, is GPS or Wi-Fi or some other manual alignment process. You could also imagine over time being able to collect more area descriptors. And as we connect more and more of those, we have enough GPS and Wi-Fi based constraints to give us a global coordinate system, or global reference to the coordinate system.
So if I anchor, for instance, a window and I tell this is the latitude, longitude, latitude of this window,
Yep.
As I scan the room, it can give me this, automatically reference me the other window that should be the longitude, latitude for that window?
Yes, so you will know your offset to the window.
Right.
And then you can apply the positional coordinate system of the window to your data set.
Okay, thank you.
Yep. Great. Well, thank you very much, and I hope you guys check out our sandbox.